we got to break it up. So the first chapter, chapter 18, is where we do most of the theory on multi-tenancy and where we're bringing things together. So we start off with like, what is a pipeline? We talk about pipelines throughout the book. We don't really get into what a pipeline actually is. So we start there, and at its simplest form, hey, you're going to commit something to Git. You want a container to come out of that, and you want that to then get rolled out, right? And then we dig into, well, you probably want to do some scanning. You might want to take a look at different things. What else is going on inside of the build? And then, another thing that we wanted to get into was, the big difference that we are often talking about in between enterprise Kubernetes and, more like service provider Kubernetes is that enterprises have policies, right? Like they have change control boards. They might be called different things. But at the end of the day, a Git commit doesn't replace the policies that have been put in place to meet their ISO compliance or various regulations. And so how do you now map that automated pipeline into that manual, that process that was designed in the 70s probably from some ISO document that says, the council of change control must meet and all vote on these changes, right? So we wanted to build that concept in as well, as that there's got to be some kind of accountability for for a human, right? To say, I approve this change to move across environments. So we get into that too. We also start talking a little bit about like opinionated platforms. I really like Kelsey Hightower's quote about Kubernetes isn't a platform, it's a platform for building platforms. And one of the things I always find hilarious about that is he was absolutely right, and I think he was absolutely wrong. He was right because that's the way it should be. He was wrong in that that's not the way we want it. Right? Like any developer who's ever built something that was not meant for production, right? It was meant to be a stand-in, or it was meant to be a placeholder, or it was meant to be a POC. And then all of a sudden that's what people are using. It's like, okay, there's no solution, no solution more permanent than a temporary one. And so where the original intent might have been, okay, you're not going to just launch Kubernetes. You're going to design a platform on top of this and then launch that. That hasn't really come to fruition, right? Like we buy AKS, EKS, GKE, we buy different on-prem versions, or we deploy with kubeadm. But at the end of the day, we're building our own platforms, right? We're not buying a vendor platform. So the next couple of sections really get into
Mark, just to discuss a little bit of that. But people know that I work for AWS, right? And the being a platform is very abstract term, but a lot of people ask for something that I don't think is what they want, because sometimes what I get from end users is, how can I have a platform for Kubernetes? Well, when I ask, what do you mean? Like, what do you want? I want everything. I want the pipelines. I want the multi-tenancy. I want the dashboard. I want it's like putting all these things inside Open Unison, and then I'm going to charge you fairly for the thing that you want. It's like, oh no, but we don't use that thing in our environment. We use the kernel, or we use Rego. Oh no, for scanning we use this tool from this vendor. We use that. So it depends your building blocks, right? The platform becomes always going to be building blocks, because everyone is at different stages because of where they started or where they are. Like I'm using this tool, I'm paying some money for this tool for scanning. I choose kernel, or I use Rego, or I choose Vault. I don't use the secret manager from the cloud. But the people are coming back saying, I want a platform that covers everything. That's not what they really need. What do you think
Yeah.
about that, right?
No,
Are people
you're
asking you
100%
to put all
right.
these features in open unison, and you're having a dilemma of like, do I build this on, and then how do I charge? Because I need to charge, because I need to build it.
Yep. No, you're absolutely right. I mean, it's the dilemma is, so like my first job I was actually technically still in high school. My first IT job, relatively small company, about 150 people, and they were using an ERP called Scopus, which, if you've ever had to deal with ERPs, they were eventually bought by Siebel, who was bought out by Oracle, right? And blast from the past. This thing was built in TCL/TK, and it was highly customized. And when it became time that everybody said, okay, we can't upgrade this thing anymore. We need to move to something new. And the IT people were all like, okay, we're going to buy something and we're not going to customize it at all. It's going to be 100% out of the box. So that way we can upgrade it. And like, I'm sitting in this meeting with the CFO who was running IT at the time, and he's listening to all of these statements. And then at the end, he goes, I get what you're saying, but no, the business required these customizations. We are not going to change the way we run our business to make your lives easier. That's not what I pay you for. And that like resonated with me because it's still true today, right? Like, we want to have a one place to buy everything, but our environments are all different. The way we do business is different. The way our missions run are different. And so they all kind of rhyme. Like, they look kind of the same. They have similar patterns. But like you said, if I'm a shop that's using Rego, right, for 3/4 of my authorizations, I don't want to have to learn Kyverno to go ahead and start doing Kubernetes authorizations. But at the same time, if my vendor says, well, our preferred solution is like, I think Amazon, not Amazon, Azure. I think, no, they're based on OPA. I thought there was a cloud provider that was based on Kyverno, but so maybe it's a bad example. Or like GitOps, right? Like, if I run Argo across 4 vendors, and now this one, I know Azure, their built-in GitOps solution is built off of Flux. Well, I don't want to have to maintain a different system. And so that's why it becomes so important to understand how all the underlying pieces kind of connect, because ultimately you're going to find you're building your own platform anyway. And that's what I find, at least my users, a lot of them have done, is they've ended up building their own platform built on Kubernetes, but Kubernetes is still the star of the show. Like, it starts there, which I think was not the intent of Kelsey's statement. I think the original intent of Kelsey's statement was Kubernetes might be in the background, but you're interacting with some other API. And what I think we've found over the years is that the Kubernetes API, it ain't perfect, but it's good enough for like 90% or 85% of what you need to do in your platforms. So why bother adding abstractions on top of it when those primitives already work? Deployments and stateful sets work for like, and jobs work for like 80% of your use cases. Why are you going to add another primitive on top of that? And so I think that's a big reason why Kubernetes has become so prevalent, even in the intent that it's supposed to just fall into the background.
Yeah, I think the Kubernetes, to an extent, I don't want to offend anyone, have become kind of like an ESB, right? In the integration service bus, it used to be like you use these rules and principles to interchange information, right? Integrations. Kubernetes have become that. Like, these objects have a spec, has a status. Somebody writes some code to use it as a schema, and then it's easier if you build these days. If you build software to run that software or deploy it, as a vendor, right, over-the-counter software, it has to be a container, and it needs to have been tested in Kubernetes, because that's where like people are integrating things, right? But Kubernetes doesn't have to be the top level, the interface to developers, right? But people are writing the APIs or consuming APIs. I think that's where like the friction starts, because those folks, you know, they want to know, as every, I guess, engineer or developer or IT person, we're curious by nature. We're want to learn. I mean, curious, like, oh, but to be able to really be good at something, I need to understand how it works on the net. I think not everyone is like that, but I think most of us, at the end of the day, are like that. I think everyone, if using a computer, or like at the age of using a computer, at least myself, I started like, I want to build one. Like I want to know what a motherboard is. I want to know what a CPU is. I want to know what memory is, and this kind of, I build compute. Like today, I don't want to build a computer ever. So that's how I feel with Kubernetes. I don't want to configure etcd or tune etcd or work with authentication of Kubernetes or OIDC kube proxy provider. Like that's not fun. I just want kubectl. Like give me the config file, and then that's it, right?
Yeah,
So
I
it's
agree.
kind of
I
a
think my Google feed
sorry, go ahead, Scott.
yesterday. I was in my Google feed yesterday, guys. It was talking about 2025, right? And I'm going to say just IT, but Kubernetes being a big one, like IDPs, right, for developer portals, which kind of goes what you're saying, Carlos, right? Let's mask this and let's make a portal where you dump your code, similar to what Mark's demonstrating in this, to be honest, just at a different scale. And one thing I found unique or interesting was the fifth point in this whole thing was Kubernetes will deploy your VMs. Now, granted, we know KubeVirt and stuff like that, right? But they're talking not just KubeVirt. They're talking, okay, you're just going to go here. So stuff like forget Virtual Center, right? Or forget anything. You're going to say, okay, cool. We've already got this excellent API. That's the data center API. And what else can we add to it? For good or bad, right? Again, I don't want to say what's good or bad, but I think it's a great idea for that. And IDPs, though, and platform engineering is really 2025. It is a big thing.
And to that point, there's a project that they had it on the Kubernetes podcast maybe 4 or 5 weeks ago, that is just breaking out the API server from the scheduler. So that's basically a way to host CRDs
KCP?
without it being called a CRD. That might be it. And yeah, I really do think that over the course of the next couple of years, you're going to see the Kubernetes API really become the data center API. Because while it's not the greatest API, it's definitely got things that I wish it would do differently. It's good enough. And I do think you're going to see a lot more of reliance on the API. I mean, like we talk about throughout the book, right? Like, especially the secrets chapter, we talk about a lot, where it's like, look, don't, this hybrid of trying to say, well, we're going to mount secrets through a volume versus just calling the API. It made sense at the time, but today that's a really painful thing to manage, right? There's a reason why ESO is so popular. So yeah, no, I definitely think that the concept that Kubernetes is going to get boring ain't going to happen. Not anytime soon. We're a long way off from that.
Yeah, and it's in the interface, like Kubernetes is becoming common. A lot of books like this one, right? A lot of like content for learning, certifications. Like it's just there. It's becoming the, like, where do you run this? Like pick Linux, right? Nobody's fighting over Linux or on how to do that. I think Kubernetes is doing that. But in this chapter, one thing that you talk about was that very important is access, level of access. Like we are saying here, like or maybe access or requirements, meeting the requirements, right? So developers can fork, developers are viewers, developer administrators, and the build process and deploy process.
Yeah, I mean, it's one of those things that I think a lot of people tend to skip, is what are the roles in the system that you're building? And this is true of any system, not just a Kubernetes platform, because it's not just based on who you are, but it's the context, right? So like in the development namespace, we're going to give developers administrative access so they can do what they need to do. But in production, we're going to want to cut that down, right? So we're defining different roles, and those roles are different based on context. So there's not a lot of rocket science here. It's just if you were to sit down and think about what does that look like, where things get really interesting is then mapping that role across 1, 2, 3, 4, 5, 6 different technology stacks to make all of this work. And this is a pretty simplistic design. Like this does not get particularly deep.
But but it's deeper than some other articles or blog posts that just like think about like there's an admin and a developer, and some systems just assume the same person have both hats. In enterprise, I like that you created. I think I particularly like the owner, the application owner that is kind of like and we see this in the enterprise where I was asking an end user yesterday, like how many, I like to ask like how many developers do they have? And they look at me like, why do you want to know that? Well, it's context, because if you tell me you have 10 developers, then I can give certain prerequisite guidance, right? But and then this particular told me like, well, we have 100 or 200 users. Well, then I can know like what level of access they need, how many teams they have, and things like that. But then you talk to someone like Adobe, and Adobe have 5,000 developers, right? In those contexts, as enterprise, you have owners, you have team leads that are the ones like are going to scaffold the project, the pipelines, like that's done maybe in the first 2 weeks, and the rest of the team doesn't have to do that. Just one person needs the access, and then that person gives access to the other people, and you have that delegation system here, right? Of like granting access to these roles to grant access to other roles. So there's no bottleneck of always going to the same person or the same role to get access. That something that you wanted to illustrate in this book? I think I got it from reading the different roles.
Yeah, I mean, and again, this is where I think the enterprise side comes in, is understanding that there's a difference between the role, and the word role in the identity world usually maps to some kind of a business function, and the permissions that role grants in each individual system. And then also the other side of it is, okay, if we're going to design this in such a way that the people who maintain the system aren't getting in the way when people make decisions, because that's the easiest way to end up in front of the CIO's office, is to become a bottleneck, right? Because like, oh yeah, we're going to do blameless postmortems, and we're all going to hug ops, and we're all going to, and then we get the finger pointed at us. And like we all have goals, like we want to be the person that's just like, oh, we're all going to be there for each other, and then the finger gets pointed at us because ultimately somebody has to be responsible. And so when you're designing your platform, you want to be in the least likely position to get the finger pointed at you. And so that means empowering your users, putting them in the position to be able to make those decisions like, oh, I need to onboard somebody. That's your responsibility as an owner, not my responsibility as a platform engineer.
Yeah. And I think you also, in here, you also like, for practical reasons, like it's always good to have books that have like not just theory and theory over theory, like container registry. Well, here are like the list of 5 different ways that you can do a container registry, from open source to run your own to a vendor one. But I like that you say like, well, as an example, I'm going to pick a certain stack that is the ones that you pick throughout the book to put it together to build that multi-tenant platform. And I think there's an architecture here where that you were saying like, do not become a bottleneck, because no one, if you implement something like this, no one can go to the CIO and say it takes forever to get a Kubernetes cluster to deploy an app, right? Now you have a system where you can say you click something or you request something or you create a file. Here you go. You get a V cluster for your team. How do I get access? Well, you have a role that can grant access. I grant access to the people that you want. Well, how do I deploy to it? Well, it's already connected to GitLab to deploy only to that V cluster, and you don't have to know about the other V clusters. And then get started. And then once you want to create the other environments, it should be similar way, just with less access, right? Developers don't need access to the production. I think you mentioned that in the book, right? You don't have to give access to developers to all the environments, and not every role will have different level of access in the different environments.
Yeah, I mean, the one of the things that we try to consistently do throughout the book is say, look, here is a stack, right? Here's an application that embodies what we're trying to show off, what we're trying to teach you. But we want to make sure we're giving you enough theory behind it, because that this was a stack we went with, and obviously some of this I'm biased, right? Like, let's be real. I'm not going to sit here and say don't use OpenUnison, use Keycloak and Dex, right? Like, call a spade a spade. But like Argo and Harbor and Vault and GitLab, like we chose those because they work well with the book and what we're trying to show off. But it's in no way like these are the best products to use. Like Harbor I really like because it's got a nice API. It integrates well with IAC. We were able to integrate with it real nicely with OpenUnison. It's got powerful OIDC tools. It's relatively easy to get up and running, and it supports multiple artifacts, not just containers. So I thought that was pretty cool. Vault, there are opinions right now about IBM and Vault and Hashi right now, but it's a tool that a lot of enterprises use. I don't think it's going anywhere. Argo. I will say I love Argo CD. I'm a big fan. I like GUIs. It works well. It's extensible. That you can do some really interesting stuff with it, and we do some really interesting stuff with it in the book, in this chapter. GitLab. I have yet to see an open source platform that is as competitive to GitHub as GitLab. Right, like it's got its own CI/CD. It's even got its own issue or Kanban boards, and we don't get into stuff like that. But it also has a pretty nice built-in identity system. It's got a pretty expansive identity system, which made it a good fit because we could define all these different roles. We did include Tecton in the second edition and first edition of the books, and decided to remove it.
I noticed that
because, I don't think Tecton really knows who they want to be when they grow up. Like the platform itself.
Good description.
It's one of these platforms that was clearly designed by engineers, in that it was so customizable, and you can do so many things with it.
It's a programming language.
And so it was complicated from that standpoint. It hasn't gotten a lot of adoption.
That's the main problem. That's the main problem that I see. But a lot of people are like good in terms of pipelines. I would say from the customers that I talk to, right? I don't talk to a lot, but a lot of people use AWS, and I talk to more than 50, 100 customers. And is Azure DevOps CI/CD pipelines very popular? GitHub
Which
Actions.
I don't understand, but
that's what they're using when I ask. GitHub Actions, GitLab, and then a lot of people use Jenkins. And they're asking me if they need to migrate or not migrate. I told them it depends. If you have support with Cloud Bees and it's working and you're not extending it, then keep using it for certain things, and then remove like things that you do in Jenkins that don't feel native. Or just remove them, replace it with something else. Move stuff to Argo CD, right? And just like and then just leave it maybe for building a container and push it into a registry. Like then that's it.
Well, and also, I mean, you've had Apache Airtable, I think it's called, for a long time. That was really popular. Um, I had a lot of customers that were using that back in the day. And Argo Workflows
Argo
is,
workflows, yeah.
Keep an eye on them because they're, a workflow is a workflow. And if you've got something that can do it, I mean, smoke them if you got them. So it's a crowded space, and Tecton got some very focused adoption. Like I think the U.S. federal government really likes it, especially with OpenShift adopting it as
OpenShift,
its
shops,
its
it's
own
supported from
internal.
them. So
Yeah, but yeah, I don't know that. I'd be surprised if Tecton gets wide adoption based on where it is and where the industry is. So we decided to take it out just to simplify it and make it a little easier to deploy everything.
I think it was a good call to just punt into GitLab and CI/CD for that. Also, just for a heads up, there's also something called Git that I use in one of my projects in GNU. And Git, I believe, has GitHub Actions compatibility. It's open source, runs in one pod, but it's for like demo purposes, right? If production wise you want to get something like GitLab. So to close, we're almost up to time, but just to close, the next chapter will be around. This chapter didn't talk about the portal, right? And backstage and those type of things. I think the next one we're going to talk about that.
Yeah, so this one we focus on the we dive into kind of the mechanics of what's going on behind the scenes. So like we get into things like how do you securely talk from one node we've got 3 clusters set up. How do we securely communicate between those clusters?
Yep.
Right? From an API perspective. Bring in what we talked about in earlier chapters. We also get into pushing and pulling images using image pull secrets. What does that look like? We talk a little bit about infrastructure as code and the difference between a Pulumi and Terraform versus an Ansible, and why you might want to think about how those look. And then we start workflowing from the business standpoint, not from the technology standpoint. Kind of like what are our swim lanes? Who's responsible for what? Anybody who's designed a large scale system will recognize a lot of these steps that you really want to do. I know a lot of times I want to roll up my sleeves and just start programming, but this is all the stuff that you got to do. And then one of my favorite diagrams, and this is actually a lot simpler, but it's got a lot because we removed Tecton, is on page 581, at least of the PDF. I think it's the next diagram from there. Is I tried to build an object map of all the objects you need to build across these clusters to make it work. And there's a lot of coordination that has to happen to make this work. And it's one of those things that when you actually demo it and it all works and you're just like, oh yeah, that's what I would expect. Any idea how much is going on behind the scenes?
Yeah. Mind maps also are helpful for diagramming these type of things. Yep.
We also talk about, and we talked about this in the secrets section, but we talk about secrets and why you should never, ever, 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 ever store a secret in Git. I don't care if it's encrypted. So we get into that, and then we start talking a little bit about identity, internal developer platforms. We don't actually do backstage because that would just be another component to have to figure out. And I'll be honest, I had some really strong opinions about backstage. And I just didn't want to clutter up on that. But to answer Francisco, we do cover this in chapter 9, I think, but the short version is that if you put a secret in a Git repository. Git is designed to make it easy for you to share things. Secrets, you want to control who has access. So if your secret, okay, never mind. Yeah, so this was a fun chapter to write. This was kind of all theory. And then next chapter, we actually put the pedal to the metal and build this out. And about the first half of it is actually like, okay, what are you actually going to build this on? And how do you build a home lab? Which became a lot of fun to kind of work through. It wasn't really where I intended it to start, but that's what it ended up being. And then the second half is when we dive into like, okay, let's deploy this thing.
Okay, the next chapter. Okay. Yeah. Okay, I think we'll cover that next week. We're out of time right now. We have more people joined as we were talking. We got up to 15 people. So thank you so much, Mark and Scott, as always, for joining these meetups and